have to be very, very honest with you right now, because when you come to an event like Seiko Open Weeks 2022, it is for nerds in a positive way, because if it wasn't because of all the brilliant people that makes inkjet actually work, you would never be able to buy a machine that actually can deliver the fantastic output that we see daily from a lot of things. And I don't think I am saying anything wrong when I say that you are a nerd, right, Tri?
I am, yeah.
And Tri, it is, first of all, it's a great pleasure to meet you. And I must say that I feel extremely stupid right now because I'm talking to such a brilliant person like yourself. So, but besides that, let's talk a little bit about what you do. And I mean, the first I moved to this because it has a graph, but you do this one. Right?
That's right. So,
and that is actually extremely important.
That's the key part. That's the brain of the what we call is the rheometer.
Yeah.
So we develop what we call is a very high extreme bespoke rheometers, especially for inkjet applications. So what do I mean by rheometer is it basically measures how viscous or liquid the ink is. But because in the inkjet, one needs to remember is because we are operating in a very high frequency and a very small geometry, microfluidic. So it is very important to characterize the ink flow behavior in the channel during the waveform actuation. So the tools you are seeing here is what we call is the TriPAP. It's a high frequency rheometer that can measure the viscoelastic, not the viscous, right? It's a viscoelastic properties of the ink at the jetting conditions, at the frequency and the print.
And one of the funny things that you showed us on the screen just before was that actually you can have the same ink, but under different conditions it behaves entirely different.
Exactly right. You're bang on the point.
Yeah.
So this is the reason why I keep asking people back. Let's say if you have a CMYK color, the inks are formulated by the ink chemists exactly to printed specification. Yet we end up developing a new waveform, each waveform different. So there is what we call is a dynamic property that is missing. And you need to match that dynamic property with the waveform, the print conditions. Because it is different, you cannot match it. But this tool allows you to quantify that dynamic property, what we call is ink physical fingerprint.
Yeah. So, and just to, we will get into details in a moment as well. I was just, because basically that means that when you go to create a inkjet machine, and let's say you want to do a CMYK machine, what you basically, when you talk about the fingerprint, is basically all the parameters that you measure and the properties of the ink in order to make sure that you maximize the output of the print heads in order to get the requested output, right?
Correct. So the industry is moving into two things, right? We want the high frequency because you want to print more drops out of it. Means you're going a much shorter time scale, and you want to print it faster, high velocity, right? So you're moving the window much narrow. So the dynamic property now becomes much more important in terms of how the viscoelastic behavior of the ink. So any simple think about ink you think is a very Newtonian, which viscosity doesn't change is actually changing a lot. So for me, there's no ink called a Newtonian. Everything is a viscoelastic. And it's the ratio of the viscous and the elastic that really defines whether the ink is good, reliable jetting. So if you really want to push the boundary of the inkjet, whether in the 3D printing or high solid load, you really have to control this dynamic properties.
And of course, this leads to why this is interesting and for who it's interesting. Because if you buy an inkjet printer, this is not something that you should be concerned about. This is something then when you are in the labs developing both inks and print heads, right?
So this is now coming for the ink manufacturer. It's a critical part because even if every resin batch they get is a different batches would have a different behavior to it. So they will have from the formulation, it speeds up the formulation because you can make a reliable ink every time. From the printed manufacturer, quite a lot of printed manufacturers are using because for the waveform development, they get lots of ink. So if they can now match the fingerprint of it, they know exactly which waveform will fit better.
And it's of course because the shape of the waveform is also how little water you can fix if it's a water base, how little water you can actually get away with because you want as little as possible. Right?
Yeah, so the water is not aqueous ink. That's a printed compatibility point of view material. But from the jettability point of view, even the printed that said they cannot use aqueous, they can get it. Just that the shelf life is not short, right? Because of the material compatibility of it. So, but the water again has a very different behavior in terms of the surface tension and all that. It completely changes how the dynamic and how the dissolved gas absorption takes place.
The reason I was asking, and maybe it's a stupid question, but I take my chances.
No.
I was just thinking because I mean, when you look at water-based inkjet, which is, for example, when you look at commercial print that is really developing these years, you basically want the water-based because of sustainability.
Correct.
You want the inkjet, the water-based, also because it's relatively cheap to add as a carrier for the pigments or whatever you use. But it's also because, I mean, and the challenge is, of course, that when you use water, you want to get rid of the water as fast as possible. And there's a physics to it, right?
Right. That's good. People think water is easy. Actually, water is the most complicated thing you think of. Think about the water has a very unique properties, right? The water is the key part of the inkjet when you do the printed specifically is the viscosity and the surface tension. Water surface tension starts at 70 at room, whereas any solvent would be in the mid-30s to 30s. And the final requirement is the 25 to 30, right? So in water, you have to have a lot of strong surfactant to reduce that. And that creates a problem on its own in terms of the behavior.
Is that why you sometimes use purified water and you use
degassing and all that? Yes, you use that. And the control of the water, and the surface tension is because of its high surface, it has a very different way of pinching it. It pinches faster. Okay, and because you use a strong surfactant, you have a much problem with the dissolved gas and all that, and you know how much dissolved gas is issue in the printer, right? So with technique, we can even detect that. We can, because the water.
So you can basically predict it by having the
viscoelasticity and all that, because viscoelasticity is also like measuring the compressibility of it. So if you have a bubble, you change the compressibility of the sample. So we can detect that also where the one ink is more prone to dissolved gas or the not.
Okay, I think I understood what you're talking about right now. So ink manufacturers, printhead manufacturers could be customers with you.
And then a lot of additive resin manufacturers too, because the printer now, they control that, right? So they have, so before they send it to the ink manufacturer, what additives and all that to send, they really need to control that property. This is why most of the time you have a problem is one batch works and suddenly they have a new batch of resin added and the formulation goes completely wrong.
Bugger, right?
Yeah. So it's not because they haven't sent it wrong. It's within the bulk is right.
Because they
but
just
the
changed.
Dynamic is not.
So when you have, I take that you worked with this for a long time, right?
Oh, we developed it for the last 15, 20 years since the academic years.
Since the interest for inkjet is in total demand right now. How if you look at this 20 years period, how has the properties developed over the years when you look at and compare?
I think people have started to appreciate the dynamic property of the fluid. So in the past,
because you said that in the beginning it was mainly the viscosity.
That's right. Even now people talk the same, right? So even if you look at all the printed specific ink, there's the viscosity, there's the surface tension, there's density.
And,
right?
and one of the photos you showed, basically you can see how much it basically drags, as you mentioned, the satellites.
Elasticity is control. So people now are understanding the importance that if you want to quantify anything, you want to be quantifying at the condition you are jetting it at. Then it's the real conditions, right? Otherwise, you are just extrapolating the data. And what our tools helps us to measure the property of the ink at the jetting condition with the life of the waveform jetting frequency.
And back to my question, so after all the past 20 years period, has inks become better and more complex?
Oh yeah, ink has become much better, ink has become more complex, and the ink is also pushing into much higher frequency, high solid loadings, and that's almost looking closer, getting closer to the analog, right? In the old days, we used to, from the ceramic or ink, we print about 20%, 30%. Now we're doing 40%, 50%, 60%, and we are working on a project where we're even developing 70% weight. So that's almost matching the analog, but the viscosity almost tens of folds lower than the analog.
And to understand the implication of what you're saying is basically, because I asked you before we turned on the camera that, you know, sometimes from a layman's perspective, you often think that why should you always buy your inks from your manufacturer? But that basically means that maybe it's a money machine for the vendors, but it's also making control on the frequencies and the footprint of the
fingerprint.
The fingerprint,
What they have done is, by controlling that, they have knowingly or unknowingly, they have controlled that dynamic property of it. So if someone is to make a generic ink, they can get the viscosity, but they have not been able to characterize the dynamic property of it. And that's why it jets completely different.
So when you measure all the things that you do with this device here, I mean, are you interested also in, let's say, gamut and things like this? Because does that have anything to do with
color gamut? We don't do. We would do the physical. We will predict how it will jet. What is the maximum print frequency you can jet with this ink? Or does that ink need a different waveform? Or if it needs a what operating temperature you need to be. Just like inks are jetted at different, because each fluid has a sweet operating temperature. We can even narrow it down. That's why if you do like a textile ink, you might be doing a 30 degree. If you're doing ceramic UV, you may be doing 40, 45, independent of the viscosity.
The reason I was asking, and maybe it's, I come from the music industry, when I was playing synthesizers, some of the things you do with synthesizers, not related to this, is basically you use the overtones and the resonance of the frequency.
Correct.
And I was basically thinking that maybe to some extent that some of the properties in a physical environment could actually be...
You're perfectly right. So what we call this is an acoustic device, we call it. So it's got a Helmholtz resonance.
Okay.
So every fluid would have a Helmholtz resonance to it. So our technique will even determine what the Helmholtz resonance of the fluid is.
Fantastic.
And that tells you how quick the wave will travel in the channel and how quick it will meet. And that will define what the waveform features is. So waveform is designed to match with that acoustic part.
And that was also one of the drawings you showed, because basically you want to make sure that you hit the hole in the printhead at the right time, in the right...
So what is inkjet? Inkjet is about pushing the right drop, creating the right drop at the right time, at the right place.
Yeah.
Right? And that's the subtlety we are doing. So, and then it's a multiphysics driven, so you need to control the waveform, how you drive it. Also, you need to control the ink, and then you have a choice of the printhead. But once you decided on the printhead, you have only two variables, right? The ink bulk and the dynamic, and the waveform.
Yeah.
Right?
That's the two things you can control.
And the temperature where you want to get it. And that's what we are trying to minimize that and quantify that in a much more precise, what we call is ink physical fingerprint. So if I get the fingerprint right, jetting is a physics driven.
Yeah.
So I need to get the fingerprint right of the physics fingerprint, physical fingerprint.
Yeah.
And the chemistry is what they do the substrate interaction and all that. It's the chemistry driven.
Yeah.
And the material compatibility is the chemistry driven too, the printed material.
The future of inkjet?
I think it's super bright.
Do you have any opinion about it? Or?
I think we are going to see more and more digital conversion of it.
Faster?
Faster, because I think people are adopting it. And there are certain applications which will be much more faster converted than others. But I think every analog, certain percentage is slowly converting. And some of the work we do as a consultant is converting those analog paint enamel product into digital.
Some of the concerns that people sometimes have when they convert from analog to digital is ink cost. The actual ink cost, is that the same, or is it more politically and business decided? So
cost of that, so I do a lot of work on the coating industries and all that, and on a digital. So when I do formulation for the coating industries, the cost becomes an important factor. So whenever someone sells me the additives, the first question I ask, how much is it, before I decide to do, because that is a 10-20% of my raw material formulation cost. When I make a digital ink for my client, the cost is the last thing I worry about it. For
because
me,
you need the properties first.
I need the performance first, right? Because there's a lot of markup in the price, right? Think about the ceramic ink and all that. In the 2010, we were selling it for 100 euros a kilo. Now you get it for 10-12 euro a kilo, right? So you can see how big the margin is.
Yeah.
So it's the performance people are willing to pay for it if you get that. So the cost is not a big issue when you're converting analog to digital.
But I was thinking that the concern is that if you move sheet offset, for example, web offset, to a digital, then it's like huge volume.
Oh yeah, huge volume. I don't think we will convert everything into digital, because there are certain things where you need but if you want to do something customized, short print and all that, digital will make it.
Tri, I just stopped now because it was really
fantastic
talking to you.
I've been following you a lot. It's great.
Thank you. Good to meet you.
Yeah.
And I actually learned a lot. I have learned, this is the fourth interview. It's been a fantastic day so far.
No, it's fantastic. No, it's fantastic.
Thank you.
Have a good day.
Good to
Enjoy
see
the rest
you.
of the day. Yeah.